right, so here we go. Dividing fractions is easy as pie. We flip the second fraction and we multiply. So what we're going to do here is, looking at this piece, we'll keep it the same, correct? But let's factor it. So talk me through this. Let's factor it at the same time. So we have 2x squared. That doesn't factor. Divided by, let's factor this. It's quadratic. We do what multiplies to be a times c. So it multiplies to be -2 and adds up to be b, which is -1. 1 times 2, correct? Which one's negative? 2. All right, so now we know that this can quick factor because our leading term is 1. So we'll have our parentheses here, and that will factor to be x plus 1 and x minus 2. How many of you were able to get that far? Okay, awesome. Then we're multiplying. We flip the second and multiply. So this is going to come up here. This is going to come down here. So on top, we have our x plus 1, and that doesn't factor. On bottom here, we are going to be able to factor that. It's quadratic, yes, but isn't there something in common here? A 2x, so we'll pull out 2x. So then we'll divide both by 2x to see what's left over. This is where a lot of people mess it up. 4 divided by 2 is 2. X squared divided by x is x. And then minus 1. Very good. All right, now remember, from this point, we could then rewrite this all over one fraction. Because we know multiplying fractions, you just multiply straight across, right? So we could multiply straight across, but we would want to leave it in factor form. And we could also say, well, we know we're going to be dividing out factors on top and bottom, as long as they're exact factors. But let's state the excluded values first. So that's when the bottom equals 0, that would be a problem. So we've got to make sure that doesn't happen. So x cannot equal what for that piece? Very good, -1. For this piece, 2. For this piece, 0. For this piece, positive 1/2. Is everybody comfortable with that, or any questions on that? Okay, so now we can go ahead and divide out exact factors. We have a 2 on top, anything on bottom that can divide out with that. 2 over 2 is 1 over 1, correct? General rule of thumb, if it's multiplied, you can divide it, right? X squared on top, x on bottom, right? So we get an x on top. We have an x plus 1 on top. So we have x plus 1 on bottom. Okay? All right, so that's it. Like, what's left over? 1 times x times 1, which is just x on top. And on bottom, we have 1 times x minus 2. Let's leave it factored. And then we have a 2x minus 1. Right? So this is our final answer. How many of you got it 100% correct? Awesome. Those of you that didn't, do you see where you made your error? Because that's just as good. Okay. Awesome. Let's get going with what we're doing today. So today's probably one of the hardest lessons of the entire unit. Not because the math is hard, because there's a lot of room for error, and a lot of people start doing weird things that they shouldn't be doing. The people that struggled less were the people that just literally showed their work every time. There was this kid who literally did not get one of these wrong. He literally did not skip a step every time he was showing his work, and he wasn't doing the mistakes that all the other people were that were skipping steps. And I'm not just saying that. Like, I was like, whoa, you literally have not got one right, like one wrong here. And he was like showing every single step. And I just think when you don't, you start getting confused with what you're doing. So keep that in mind as we go through this. So today we're going to be adding and subtracting rational expressions. So remember, so far in the unit, we've learned how to simplify rational expressions. Then we've learned how to multiply and divide rational expressions, which is pretty much the same thing as simplifying, but one extra step, multiplying straight across, and then simplifying. So today we're going to be adding and subtracting rational expressions. So let's remember by hand how to add and subtract just fractions or rationals. Remember back to adding and subtracting rationals by hand. You have to have a common denominator to be able to add them. This is very different than multiplication. Multiplication, you do not need a common denominator. So if this was 2/3 times 5 over 2, we would have no problems. All you have to do is multiply straight across. Does everybody understand? But since this is addition, we have to be able to add these. We have to have a common denominator here. The bottom has to be the same. So what we're going to do is say, what's my least common denominator? So we go off to the side and figure out the least common denominator. The reason we want the least amount, the least common denominator, is there's less simplification involved if you do the least common denominator. All right, so in this denominator right here, there's a 3, correct? Okay, awesome. Now we have a 2. Now understand, this is one really important thing that I always see students try to do the first time we learn this. They think you can change denominators by addition or subtraction. So they say we just need to add 1 to make this a 3. You cannot change denominators by addition or subtraction. It has to be by multiplication. Does everybody understand? So we would say to ourselves, okay, can we make a 2 a 3? No. So we're going to have to add a 2 in there. Multiply a 2 in there, technically. So our least common denominator is 6. Does everybody understand? So how are we going to make this denominator 6? We're going to multiply by what? 2. Well, if you do that to the bottom, you've got to do it to the top. Now notice, we're not changing the problem because isn't that just a fancy 1 that we chose? Okay. Now I'm going to multiply this denominator. I need it to be 6, so I'm going to multiply by 3. But if I do that to the bottom, I've got to do it to the top so that I'm only multiplying by a fancy 1. Is everybody good? Now we know how to multiply fractions. You can just multiply straight across. So we have 2 times 2, which is 4, over 3 times 2, which is 6. And then we have plus 5 times 3, which is 15, all over 6. Now, do you see how we both have a 6 in the bottom? Now it is appropriate, it's absolutely okay to put this into one fraction. We add straight across, but you don't add the bottoms. We have 4 6 plus 15 6. How many 6 do we have? 19 6. And that would be our final answer. If you understand that, then you understand how to do rational expressions. It's the same idea. Get a common denominator, add straight across, and then simplify. So 19 over 6 doesn't simplify, so we're done. So I want you to look at this next one. Tell me what the least common denominator is for this. Is it 18? No, what is it? 6, good. So this is how you would look at this one. You'd say this one has a 3. Now you look at the next one. This is a 6. Isn't 6 already have a 3? So to make it a common denominator, we'd multiply by 2, correct? 6. You get what I'm saying? So now looking at this, we need to make this 6, so we're going to multiply by 2 over 2. Now do we need to fix that fraction? Nope. So now we can multiply straight across. We have 4 over 6 minus 5 over 6. Now that we have a common denominator, we can put it over one fraction. 4 minus 5 is negative 1 over 6. Does everybody see how to do that? Same thing for rational expression. So here we go. Once again, when adding and subtracting rationals, you need a common denominator, and we want the least common denominator. So in this denominator, we have a 3, correct? The hardest part is honestly finding the least common denominator. So we have a 3. Now in this denominator, we have a 2 times x. So we're going to have to put in a 2 and an x, correct? Okay, so our least common denominator is 6x. So we need to make this 6x. What are we going to multiply by? 2x. If you do that to the bottom, you got to do it to the top. Very good. And over here, we're going to multiply by 3 over 3. And now let's make sure. So this is the step that usually people skip, and then they start to get confused. So we have, when we multiply straight across, we have 4x squared, correct? All over 6x. And then we have minus, multiply that, 15 over, check it, 6x. Make sure those are the exact same. So now you would say, okay, good. We're at our last step. We can put it over the same fraction. So that would be 4x squared on top minus 15. Those are not like, so we can't combine them, all over 6x. Is everybody feeling good about this? So now we're to our first day's lesson where it says, can I simplify this? So we would say, does this factor? And I'm telling you it doesn't. We're not going to spend time on that, but it doesn't factor, so we're done. Does everybody understand? Pretty simple, right? All right, now people on the test start to miss things because they get the ideas confused. They see this and say, I need a common denominator. Isn't it multiplication? You do not need a common denominator. If you get a common denominator, you're going to get it wrong. So we do not need a common denominator here, so we would just simplify, correct? Can't we divide it out first? So what would we divide out? 2x and 2x, which would become 1s. So this would simplify to be 5/3. Is everybody comfortable with that? Multiplication versus addition. Do not get a common denominator with multiplication. All right, going here. So if you turn to 4-3, because that's what we're learning today, these are the notes. I would take some good notes so you can refer back to them. All right, 2a, let's simplify this. Once again, it's addition. So you'd say, I need a common denominator. Don't these already have a common denominator? So then you would say, okay, awesome. Then I can just simply add straight across on the top. We're going to combine our numerator to have one fraction here. 7 plus 4 is 11, and then that's all over 3y. Is everybody good with that? Now, we do not need to restrict our domain today. we're going to assume all variables are, that we're just not going to restrict our domain today. Like, you don't need to say what y does not equal. Is everybody good with that? We're just going to focus on adding and subtracting. Now you'd say, okay, sweet, I performed addition. I'm good as long as it doesn't simplify. Does that simplify? Nope, so let's move on. Let's do 2b. Now, 2b is a well, 2b is technically a red flag problem too, because anytime I see subtraction, I need to be careful. This one we won't have to be super careful because there's only one term. All right, so looking at this one, can I subtract these? Don't they already have a common denominator? So now we can say, okay, I can write it over one fraction. I'm going to combine like terms. So we're technically doing 3x minus x, which is how many x's? 2 x's, and that's all over the common denominator of x minus 2. Is everybody good with that? Okay, we've done subtraction. Now you'd say, does it simplify? Does it? No, right? We know for a fact x minus 2 is connected with subtraction only if there's an x minus 2 on top. Can we simplify, right? Okay, moving on. 2c, here's a really big red flag problem. So don't they already have a common denominator here? Okay, so now here's the tricky thing. And even after I said this, so many people were still missing it. If you're dealing with subtraction, we know when just dealing with polynomials that we had to put it in -1 and distribute it through to everything on this side. We're subtracting all that stuff. Does everybody remember that? So you've got to do that with this as well. We already have a common denominator, so now we're just combining like terms on top. It's subtraction, so we've got to distribute this through. So what we're really looking at on top is this, 5c minus c, correct? But -1 times -28 is positive 28. And now we'll combine like terms. So this is still the top. We have 5c minus 1c, which is 4c's, correct? Then we have plus 28. So now I've combined everything on top, and it's all over the common denominator of 2c plus 7. Any questions? Okay, now what would I do? My last step is to see if it simplifies, correct? So what would I do? How do we simplify? Factor it out, right? We factor it out and then see what divides out. So on top, what do we factor out? 4. So then divide by 4, what's left? C plus 7. Awesome. That's the top factored, and on bottom, the bottom doesn't factor. So now looking at this, can we simplify? No, we can't. We have a 4 on top. Can we divide it with that too? No, it's connected to plus 7, right? Everybody? Okay, so we can't simplify. We have c plus 7 on top. Do we have a c plus 7 on bottom? No, we have 2c plus 7 on bottom. So we can't divide anything out. Does everybody understand? Okay. Okay, go to your worksheet, your homework worksheet, and do. On the blue page, do problems 1 and 2. And then on the white page, the front, do 1, 2, and 3. And then check those with me. Ready, set, go. Get those done. This is getting your homework done in time, which is always a good thing. We simplify by factoring the top. That's our very, 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 very last step. You do not simplify until you combine everything on top and put it over one of that. Check those with me on the bottom. Yep. Okay, so now you need to simplify both of those. These, simplify, factor out the top, these, simplify. Good. Now you need to simplify that one, because on top you can factor out 2. Write your final answers, you guys say, can that simplify? So then that's your answer as long as it doesn't simplify the stuff, right? Yep. Now you can't add over it, they're not always counts. So you just have to say something. So now you're simplifying out right, multiplication can be divided. If you're not doing 9 so you divide out or something. Oh, and that one. You gotta distribute your negative. Oh, yeah, so that's on 3. So 3 plus 1 plus 3 is 4. Okay, awesome. Those are correct. That simplifies and that simplifies. Those both simplify. Those answers both simplify. Okay, those are this is wrong there. Your answer is wrong here, and then that was simplified and that simplifies. That simplifies. Being on the top, you can factor on the 2, right? No. Given 24 simplified. Did a common denominator is already common? You just add the top together.
Plus to minus, divide. Make that a plus. Here, let me show you. So, I feel like put that as a plus and then flip the sign on top. I'm not sure about on top. I didn't do it.
Okay,
and then,
guys, you guys are breaking from left to right. Feeling highly concerned. Okay. I feel like we know this. Here we go. So, looking at this piece, we would need to do what? Distribute the negative. So we already have a common denominator. That would have been my first step. Sorry. So this is really a plus b. This is the top. And then we have minus a and then negative 1 times negative 3b is plus 3b, correct? So let's combine like terms. A minus a is 0. B plus 3b is 4b. That's all over the common denominator of 9b. Then you'd say to yourself, can that simplify? Multiplication can be simplified. So 4 over 9 doesn't simplify, b over b does. So our answer is 4 over 9. Okay, everybody good with that? Okay, let's do number 2. This one we should be good with. We need a common denominator. It's already common. So then you say to yourself, okay, so I can put it over one fraction. So let's write it in standard form, or even if you didn't. 2 plus 6m. Okay, awesome. All over 24m squared n squared. Then you would say to yourself, does it simplify? How do we simplify? We factor the top, factor the bottom, divide out exact factors only. So looking at the top, what's in common? 2. So let's pull out a 2. Now let's go back and correctly think about this. Divide each term by 2. When you divide those, does it just become a 0? No. That's what I saw like everybody do that got it wrong. 2 over 2 is 1. 6m over 2 is, so plus 3m. That's what we have on top, and on bottom it doesn't factor. So 24m squared n squared. Then you'd say multiplication can be divided out. 2 over 24, what does that become? 1 over 12. So left on top, because there's nothing more we can do here, is 1 plus 3m all over 12m squared n squared. Those of you that got it wrong, do you see where you made your error? All right, so go to the white page. I think we all got these ones right. We have 4 over n, correct? And then right here, what did we get? Number 3. Negative 6 over x. Did anybody have problems getting that? Because we're not going to go through it and waste your time. So you didn't get that? You forgot to distribute the negative then. That's probably where the error was. So that's a good one to be careful on. So that's negative x and negative 3, right, everybody? So then when we combine like terms, it should be negative 6x. Okay, and then this one, what did we get? 27 over 7p. Then you say, does it simplify? Do 27 and 7 divide? Nope, so there's our answer. Do we have questions on this? Those were the basics, guys. Okay, let's start somewhere we have to go back to your notes where we have to get some common denominators. So least common denominator. Okay, in this, I'm going to start with this denominator. We definitely need a 6x because that has a 6x. Does everybody understand? Now careful here. We have a 2. Isn't 2 already a 6 technically? Is everybody, like there's a 2 in 6, right? Am I making sense?
Yes.
So we're not going to multiply by another 2 because we can make 2 6 by multiplying by 3. Okay. Now this has an x squared. In our common denominator, we only have one x. So how many more x's do we need? An x. So our least common denominator is 6x squared. Does everybody understand? So you say to yourself, how can I make 6x squared? What do I need to multiply by? X. If I do that to the bottom, I've got to do it to the top. Is everybody good with that? Then you'd say, how can I make 2x squared 6x squared? Multiply the bottom by 3 and the top by 3, correct? So now let's multiply straight across. So right here we have a 5x. This is a step I would not skip. X times 6x is 6x squared. Okay, now it's addition. We don't have to be careful with anything. Plus 3 times 3 is 9 over 6x squared. Now check and make sure. Do we have a common denominator? Yes. So now we can put it all over one fraction. So now we'll add straight across. That's 5x plus 9. And it's all over the common denominator of 6x squared. We have just added 2 rational expressions. So then you say to yourself, does it simplify? Does the top factor? No. So we know nothing's going to divide out. So this is our final answer. Everybody good with that? Okay, let's do 3b. Here we go. Least common denominator. We have a 7y to the 4th, so we definitely have to have that. Let's look at this. 3 and let's focus on 3. Does 7 contain a 3? No, so we're going to have to multiply by another 3. Does everybody understand that? Because 3 is not a factor of 7. Now this is a y squared. Isn't y squared a factor of y to the 4th? Okay, so our least common denominator is 21. 7 times 3 is 21, y to the 4th. So then you say to yourself, let's focus on this first piece. How are we going to make it 21 y to the 4th? What do we need to multiply by? 3. So multiply by 3 over 3. And then we need to make this 21 y to the 4th. So we need to multiply by what? To get 3 to 21, we need to multiply by 7. And then y squared, to get it to y to the 4th, we need to multiply by y squared. We'll multiply by 7y squared to top and bottom. Is everybody good? Once again, I'm warning you, it will help you to not make an error by just doing this next step and not skipping it. 3 times 3 is 9 over 21 y to the 4th. Check. And then we have negative 2 times 7, which is negative 14y squared, correct? On top, right here, guys. All over, make sure this is the right thing. 3 times 7 is 21. Y squared times y squared is y to the 4th. Now, are your denominators exactly the same? Yes. So we would say to ourselves, okay, let's rewrite this. Let's combine our tops. And I very strongly suggest rewriting it in standard form. So our highest degree should come first. So let's reorder this correctly. This is negative 14y squared, correct? Plus 9. All over the common denominator of 21y to the 4th. Then you should be saying to yourself, does this factor? And technically, here's what you could be looking at. The quadratic, this quadratic a times c and adds up to be b doesn't factor. But if we have a negative in front, don't we always factor out a negative? So this is, if this was a multiple choice test, you would not see this answer. What you would have to see, remember is, okay, I know I'm going to factor out a negative 1, right? Because there's a negative in front. That's the only time we factor out a negative. So then divide each by -1. So left would be positive 14y squared, correct? Minus 9, all over 21y to the 4th. Now what they're going to do is they're going to take that -1 and just put it out here in front, because that's the same thing, right? So I'm just going to erase that -1 and go like this and put my negative out here in front. This would probably be how you saw it on a multiple choice test. Is everybody good with that? Okay, let's do another one. Here we go. 3D, least common denominator. This one tends to be the hardest. Now, let me remind you again of the rules. To get a least common denominator, you only can multiply by something. You can't add anything. So you can't add 9 to make that +2. Does everybody understand? Okay, so this has an n plus 2. That is connected with an addition sign. So that is connected. Now we have an n minus 7. There's no way to make that n minus 7, so we're going to also have an n minus 7. So this is where it starts to get just a little bit more algebraically involved. Here we go. So this is our least common denominator. All of our denominators need to look like that. So are we going to multiply this by n minus 7 over n minus 7? Now, if you ever have two terms, put parentheses so that you don't forget that you're going to be distributing. This one has an n minus 7. It needs an n plus 2. So I'm going to multiply by n plus 2 over n plus 2. Now, looking at your denominators, are they the same? Check, check. So now what we're going to do, make sure you do not try to start simplifying. If you simplify, you're going to divide those out, because obviously they divide out. They're a 1. We put it there on purpose. So you need to, our goal is to combine like terms on top. To do that, you've got to distribute and then combine like terms. Does everybody hear that? So let's do this correctly. 9 times m, let's just focus on top, that's 9m. 9 times -7 is -63, and that's all over m minus 7. Let's leave the bottom factored, because in the end we'll have to factor it anyways. And then we have plus, let's distribute positive 8 through. 8 times m is positive 8m, correct? Positive 8 times positive 2 is positive 16. And that's all over m plus 2 and m minus 7. Now, do not simplify right here. If you simplify, you're going to end up back here. This is what people are doing. They're then trying to simplify. Do you see how we have a common denominator? The whole goal of this was to now be able to combine everything on top. So that's what we're going to do. Let's combine like terms on top. So 9m plus 8m's is how many m's? 17m's. Okay, awesome. And then we have -63 plus 16. -47. And that's all over the least common denominator, because we just put the top together. We have just added two fractional expressions together. Now, you would say, okay, I've done the hard part. Now let's simplify. Does 47 divide by 17? Nope, 17 doesn't have any other factors, so it must not factor. So then we're done, because nothing will divide out. Is everybody feeling good about this? Yes. The bottom, we wouldn't need to. It wouldn't be incorrect if you did, but that's just extra work, because it's absolutely okay to leave it in factored form. I would almost rather you leave it in factored form. Hey, do you want me to do 3F? Okay, it will get easier. Let's keep going. I know this is feeling long, but if I set you free to work too soon, you would be messing up and we'd have to do this anyways. Here we go. So we would say we need to figure out what the least common denominator is. This has a 3c minus 1, so we are going to need a 3c minus 1. And then this is going to have a c minus 2. We've got both of those. Okay, so we need it to be this. So this one needs a c minus 2 over c minus 2. Once again, take my suggestion. Anytime you have two terms, put it in parentheses. This has a c minus 2, but it needs this. So we're going to multiply by 3c minus 1 over 3c minus 1. Okay, so now we can go ahead and look at our denominators. They're the same. So let's start distributing the top. C times c is c squared. C times -2 is -2c. That's all over the common denominator. Can I just put common denominator for right now? Abbreviate, and then in the end I'll write it. Does that confuse anybody? Yeah, as long as you're in your final answer. Is everybody okay with that? Okay, so this means common denominator, not to be confused with C. Then, now right here is where people mess up. This is subtraction. So think of this as negative 4. Okay, everybody? Negative 4 times 3C is what? Negative 12C's, correct? Right here, negative 4 times negative 1 plus 4. That's all over the common denominator. Okay, now the whole goal of doing this was so that we can combine all like terms on top. So that's your next step. Do not simplify right here. Now you've already distributed the negative through, so you're literally just taking this stuff and combining it, like terms. So we have a C squared. We have negative 2C minus 12C, which is negative 14C's. And then we have plus 4. Now we do need to write all over the common denominator, which is C minus 2 and 3C minus 1. Is everybody good? So we've done the hardest part. Now we'd say, does it simplify? So let's check this one. What multiplies to be A times C, what multiplies to be 4 and adds up to be negative 14? Obviously nothing, right? So there's our answer. Is it feeling maybe a little easier? Okay. Okay, go to your worksheet. Let's do some so you have less homework. This is very interesting and it's different. That's what's hard with these is there's just you're going to see so many different things. So looking at number 3. Now, you've got to be careful on getting the least common denominator. Here's why. People just think you always multiply by the opposite denominator. That's not true. We've got to do the least common denominator. Okay, so let's think about this one. Looking at this, doesn't that factor? So that's what we're going to want to do first is make sure the bottoms don't factor. Notice, go look at all the other examples we did. Do you see how these bottoms already were not, they're already factored. Do you see how the bottoms were already factored? Already factored. We haven't had any that needed to be factored first. So now we're getting to some where you can factor out that bottom. So let's rewrite the problem. We have K plus 4. Really, guys, if you rewrite the problems, it's going to help you. So what can we factor out here? Greatest thing. 4. Okay, so we'll pull out a 4. Divide by 4, divide by 4. So then left is 3K plus 5, right? Then we have plus 7 over 2K. All right, so our least common denominator, let's go start writing it. So definitely going to contain everything from the first piece. We're going to need a 4 and a 3K plus 5. Does everybody understand that? Now let's look at this denominator, 2. Doesn't 4 already contain a 2? So we don't need to put another 2 in there. Does everybody understand? But we need a K. We definitely need a K. So I'm going to write it as 4K, because we need a K, and then 3K plus 5. This is our least common denominator. Because this one has a K. So to make them the same, doesn't this one going to need a K too? Does that make sense? Good question. Does that make sense, everybody? That was a really good question. Because I actually have everybody has been like really thrown off by this problem in the past few classes. So actually that's probably what they were wondering. Why do we need a K? Because this one would need a K to be the same as that one. Good question. Okay, so now let's go ahead and start fixing this. Now look at this denominator. Look at it. This is what it should be. Look at it. What do we need? K. Does everybody see it? So we're going to multiply by K over K. Let's put parentheses around the K plus 4 because there's 2 terms. Now look at this. 2K. We need it to be this. So let's see. How can we make 2 4? By 2. Okay. Now don't we already have a K? Don't we need a 3K plus 5? So we need a 2 and a 3K plus 5. So we're going to do that to the top and bottom. Okay, let's start multiplying this out here. So let's focus on this piece, this front piece. So K times K is K squared. K times positive 4 is positive 4Ks. Now let's actually not multiply it out, but let's put it in a pretty order on bottom. Even though it doesn't matter, isn't 4K like the more appropriate way to write K times 4? Just in math, like we always write it as like 4K. So 4 times K times 3K plus 5. Okay, so then we have plus. Now people get thrown off by this. They say, what do I do here? Let's just multiply 7 times 2 first, which is, so we're taking 14 times 3k plus 5. Does everybody understand? Mm-hmm. So let's distribute. You tell me, what's 14 times 3? What is it? 42. Thanks, Brevin. 42k, everybody, right? And then 14 times positive 5 is 70. So then we have plus 70. Now look at the bottom. Let's reorder this in a pretty order. That's 2 times k times 2. Isn't that 4k? 2 times 2 is 4. Okay? And then we have our 3k plus 5. The kid that was not missing any would always never skip this step. I don't know why it helps, but it just does. Now look at your denominators. Are they the exact same? So we've done it correctly. It's a yes, so we've done it correctly. If they don't look the exact same, then that's, you said, what did I miss here? What least common denominator did I miss? So now that we have a common denominator, we're going to combine the tops. So we have a k squared, check. 4k plus 42k's is 46k's. And then we have plus 70 all over the common denominator of 4k and 3k plus 5. So now you would need to go off to the side and say, does this factor? So you'd say to yourself, what multiplies to be a times c, what multiplies to be 70 and adds up to be 46. 1 times 70, 2 times 35, what else? 7 times 10, anything else? Can we think of? You would test a few things, you know what I mean? Keep dividing by 3. Do any of those add up to be 46? No. And if we've listed them all, then we know that the top doesn't factor, so we're done. Does everybody understand? Are you ready to start practicing some? Okay. You don't want me to do this one, you guys are good to go. Yeah? We're good to go. I would love for you to start practicing if you feel prepared. Okay, let's do 4 through 6. So on the blue. So you're doing not just 5 and 6, you're going to do 4, 5, and 6 and check those with me so I know that you're understanding. 4 and 5 and 6 on the blue. Okay, so showing your work will help you get less confused. So you should be saying to yourself, can I factor out any of the bottoms? So rewrite your problem. 8b over 3b minus 3 over factor out of 2 left is b plus 4. Is everybody good up to there? Then you go off to the side and say least common denominator. We have a 3b, that's definitely got to be there. We have a 2. Is 3 a 2 in any way? No, so we're going to have to multiply by 2. And then we have our b plus 4. So now really if you look at that, that's 6b, b plus 4, correct? That's the least common denominator. Okay, so then you would say to yourself, let's look at this first piece. We need to make 3b this, so let's look at it in pieces. 3, we need it to be 6, so what should we multiply by? 2, okay, let's look at it in pieces. We already have a b, okay, we've taken care of that, we already have a b, correct? Don't we need a b plus 4 now? Does everybody understand that piece? Yeah. Then you look at this next piece and say, okay, it has a 2, it needs to be 6, so what are we going to multiply by? 3, it already has a, nope, doesn't have a b, so don't we need a b? Oh, b plus 4 is already good. So 3b. Okay, now let's multiply straight across. Careful here because this part tends to be the hardest for people to multiply. What's 2 times 8? 16, so we're really doing 16b times b plus 4, right? So let's distribute that through. 16b squared plus 64b's. That's all over the common, wait, let's make sure it's a common denominator. Let's actually multiply this out to make sure we did it right. This is how you can check your own work. Isn't this 2 times 3 times b? 6b? And then a b plus 4. Does everybody feel good about that? Okay, then we have negative 3 times 3b, which is negative 9b's, correct? Let's multiply out the bottom. 2 times 3. 6b and b plus 4. So look at your bottoms. Are they the exact same? So now, what do? Combine our tops. 16b squared, no other b squareds. 64b minus 9b's is 55b's. Does everybody feel good? All over 6b and b plus 4. Does everybody understand? So then you'd say to yourself, can I simplify by factoring? Look at the top. What can I factor out? A b. Guys, are we focusing? What would I factor out on top? B. Then left is 16b plus 55. On bottom, we have 6b. B plus 4. Now you look and say, can I simplify that? B over B is 1 over 1. Isn't that it? So left on top is 16b plus 55 all over 6 times b plus 4. But I'm not getting that. Like, oh yeah, makes sense now. Okay. Oh yeah, I see where I made my error. I'm not getting that. So I'm like seriously so confused on how to help you. Okay. Continue working on those. To the front. This is on your homework, so I'm trying to help you out here. Let's do 13 and 14 together. So you say to yourself, oh, to be able to add fractions, I need a common denominator. Don't we need an n over n? M over n. Does everybody see why? Aren't the denominators the same now? So we have 2n over nm plus 5m over nm. Okay, now we can combine them because they're the common denominator. But those are not the same. So we have 2n plus 5m all over nm. Then you would say to yourself, I only can divide out multiplication. There's no factoring here, so it's connected with addition. So there's our answer. Okay, let's do 14. What's the denominator on 5? 1. So what's the least common denominator? T plus 3. So are we going to do t plus 3 over t plus 3? Throw parentheses around that. So right here we have 3 over t plus 3. And then we have plus, we got to distribute. 5t plus 15 over t plus 3, right? Common denominator, so now we can combine the tops. So we have 5t plus 18, right? All over t plus 3. Does everybody see where I'm getting 18 from? Okay, then you'd say, does it factor? No, so there's our answer. So pretty easy, some of them. Okay, like for 2 seconds, we got to keep moving forward here. So, go to your notes page. Hurry, and we're going to do this. This is really good to watch. So you would not, do not, if you ever see something like this, just multiply by each other's denominator. Don't we need to factor it first, because this might contain an x minus 6 in disguise. So we're going to rewrite it. X over, factor that. Well, multiplies to be negative 6 and adds up to be negative 5. 1 times 6, negative 6, right? So we can quick factor it to be x plus 1 and x minus 6. We rewrote this piece, and then we have plus 2 over x minus 6. So what's my least common denominator? X minus 6 and x plus 1. So looking at this, do you see how if you didn't factor it and you just did it to each other's, we would have been wrong? Okay, so what do we only need to fix this one. We'll multiply by x plus 1 over x plus 1, right? Now we'll put parentheses, so now we have a common denominator. We have x over the common denominator plus 2x plus 2 over the common denominator. So now we can add straight across, right? 3x plus 2 over, now let's write it out, x plus 1 and x minus 6. Yeah, because it doesn't simplify. Okay. Okay, let's do 3h. Hurry, look at it. We would say to ourselves, let's factor this. So we're going to have 5x over what multiplies to be negative 4, adds up to be 0, 2 times negative 2. So this will factor to be x minus 2, x plus 2, right? Minus 3 over what multiplies to be negative 8, adds up to be negative 2. 4 times 2, negative 4. So x minus 4 and x plus 2. What's my least common denominator? X minus 2, X plus 2, and X minus 4, right?
Yeah.
So what does this one need to be the same as that? X minus 4, right? And then this one needs an X minus 2. Well, we have to, because the bell's going to ring soon. Is everybody good with that? So then what would we do? Distribute -3 through, and then we combine like terms on top, right? All over all that. You get what I'm saying? Do I need to keep going, or I don't want to waste your time. I want to give you some time to practice. Does everybody understand, or keep going? Keep going? Okay, 5x squared minus 20x, right? All over the common denominator. I don't want to have to rewrite that again. Does everybody understand? Then we have -3x. I'm going to distribute the negative through, plus 6, all over the common denominator. So now, can't we just combine like terms on top? So we have, oh, wasn't this 5x squared? Okay, so we have a 5x squared minus 23x plus 6 all over x minus 4, x minus 2, x plus 2. Then you would just say, does the top factor, what multiplies to be 30, adds up to be -23, 10 times 3, 1 times 30, 2 times 15, that's it? No, right? 3 times, everybody good with that? So we're good, that's our answer. Okay, so I would like you to do 7 and 8 on the blue worksheet while you're in class and check, or at least do 7. Check with me, that's probably the hardest one on the entire worksheet. So do 7. Now, cross out 9 and 10 on the blue side, because we're going to stick to the algebra one. So only on blue, cross out 9 and 10 right now, so that when you leave, you already know that you don't have to do those. You can do 11, it's pretty easy. The rest of it is homework. Now, don't get like, holy cow, there's so many problems. Literally, the front worksheet is like basic. And a lot of, half of it says, what's the least common denominator? That's it. You don't have to go through and add them. Does that make sense? So it's not as much homework as it looks. There's just some advanced ones on here. So the math lab is open today after school. I'm available. This video will be posted.